Right, here is the investigation section of a paper 6. It is all about estimating pi. It's got quite a lot of geometry in there, it's got some probability in there. It's a bit of a mix. Let's see how we get on. So, estimating pi. This investigation is about using relative frequency to estimate the value of pi. So here it says the area A of its circle is A equals pi r squared. Lee draws circles on rectangular pieces of paper. He drops grains of rice at random onto the pieces of paper. He counts the number of grains of rice inside each circle. Lee draws a circle of radius 5 centimeters on a rectangular piece of paper measuring 40 centimeters by 20 centimeters. The probability P that a grain of rice lands inside the circle is P equals area of circle over area of paper. Now, this is theoretical probability. Show that P is approximately 0.098 for this piece of paper. So what he's doing, he's getting some bits of rice. He's got his thing like this, and then he's dropping grains of rice on it, and they either land inside the circle or they land in the rectangle on the paper. So basically, the reason why they're getting this, they're saying proportionally, if you get the area of the circle as a fraction, or as a fraction of the total area, that should correspond to the relative frequency with which these grains of rice land inside the circle. That's the theory, and throughout this paper, hopefully this is where we'll be building to. Usually the first mark's quite friendly, so it says P equals area of circle over area of paper. Show that it's 0.098 for this piece of paper. Well, this piece of paper, the area of the circle, well, the circle has radius 5, so the area is pi r squared. It even tells us that the area is pi r squared, which is very friendly. The area of the paper, well, it's a rectangle and it's 40 centimeters by 20 centimeters. So P in this case is going to be pi times 5 squared over 40 times 20. And when it says show that, you really should show a long number rounding. So let's go to our calculator. Pi times 5 squared over 40 times 20. So that gives us an answer that we don't want in that form, so we need to press this SD button, and that's more like it. So that equals 0.09817. So approximately equals to 0.098. I might have written a bit too much, but when it says show that it equals this, I want to see the substitution into a formula, possibly a longer number, and then it's approximately this. There's no way they can take that mark away from me. Right, so he's got the theoretical probability that he thinks. Now he actually does it. So it says Lee goes ahead, he drops 10 grains of rice at random on the piece of paper. So he drops 10 grains of rice, and then we can see the results. So these are little grains of rice, and you can see that 2 landed inside the circle, and so the rest landed outside. This should be 8. 1, 2, 3, 4, 5, 6, 7, 8, making 10 in total. Right, so they are the results. So what do we need to do with that? The relative frequency that a grain of rice is inside the circle equals number of grains of rice inside the circle over total number of grains dropped. So again, this is really quite a friendly mark. Find the relative frequency that a grain of rice is inside the circle. Now, relative frequency is it's often called experimental probability. Basically, experimental probability and relative frequency is when you've done an experiment and you're using the results to generate an approximate probability. So it's when you're using past results. So number of grains of rice inside the circle, we can see that's 2. The total number of grains dropped, well, you can either count them, it's 10, or you can read there's 10 grains dropped here. So we need to do 2 over 10, which is fine. or you could call that 0.2, which is quite nice because you can then compare a decimal with a decimal. Right, Lee drops 10 more grains of rice at random onto the piece of paper. So he's not taken the old ones away by the look of it, he's just dropped 10 more. So there should be 20 grains in all. Show that the relative frequency that a grain of rice is inside the circle is 0.15. So now the number of grains inside the circle is 1, 2, 3, and there are in total 20 grains of rice here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that's 3 over 20, and we can, well, you should know, hopefully that's 1.5 over 10, which is 0.15, but it is a calculated paper, so you might as well use it. 3 over 20, and then the little FD button is 0.15. Okay. Right, the relative frequency that a grain of rice is inside the circle gives an estimate for the probability. The area of the circle is 25 times pi. So remember that 25 times pi comes from this circle. It had a radius of 5. Area is pi r squared, so pi times 5 squared, pi times 25, or 25 times pi. Right, so the area is 25 pi. So what we need to do now is use area of circle over area of paper equals 0.15 to show that an estimate for pi is 4.8. So what we're going to do, we are going to write, well, area of circle, we've just been told, is 25 pi. They wouldn't give it to us in that form if it's not something we need to use in that form. So I'm going to write 25 times pi over area of paper, and we know that the area of paper was 40 times 20 over 40 times 20. Now remember, this is our theoretical probability. So we need to write, this is theoretical probability, so area of circle over area of paper, which is like the area of the circle as a fraction of the total area. And we've been told to use area of circle over area of paper equals 0.15. So we basically, the formula is theoretical probability that it lands in the circle equals relative frequency of it actually landing in the circle. So where this is, I imagine, going to lead is that the more rice we drop, the closer this thing will get to pi. Because you can see an estimate for pi of 4.8. Well, that's not very good, is it? Because we know that pi is around 3.14. So if we're going to solve this for pi, well, pi is going to be equal to, so we're going to have to move everything away from the pi. So we want to multiply by the 40 times 20 and divide by the 25. So it's going to be equals 0.15 times 40 times 20 over 25. So hopefully that should equal what we want it to. 0.15 times 40 times 20 over 25, which is 24 over 5. If I just press the SD button, that is 4.8. Great news. So the way to think about this is we've basically done an experiment with 20 trials. 20 is quite a low number of trials. We're using this experiment to estimate pi. We know this because the title of the investigation is Estimating Pi. And right now, our estimate for pi is not very good. But what happens in these investigations, they tend to start with raw numbers, and then they sort of improve it a bit, and then they bring some algebra in. It's just the way things tend to go. Let's see what happens. Right. Lee draws a circle of radius 10 centimeters on a rectangular piece of paper measuring 30 centimeters by 20 centimeters. Complete this statement with a number. area of circle equals something times pi. Right, well before, remember the area of circle before was 25 times pi, and that came from the radius being 5 squared being 25, because area is pi r squared, so that was 25 pi. So if the radius is 10, well the area is going to be pi times 10 squared. 10 squared is 100, so that's pi times 100, which could also be 100 times pi. So this is just 100 for this circle. Right, so Lee does the experiment with this circle. He drops 10 grains of rice at random onto the piece of paper. Diagram A, this is diagram A, shows the results. So there are 1, 2, 3, 4 grains of rice inside the circle, and I imagine 6 outside, but I might just check. 1, 2, 3, 4, 5, 6 outside. Okay, so Lee removes the 10 grains of rice and drops another 10 grains of rice at random onto the piece of paper. So it's slightly different to how he did it last time. Before, he went ahead and dropped 10 more on the same thing. Here, he's kind of done the same experiment twice. So he's got 2 different sets of results for exactly the same experiment. So he's still used 10 grains of rice. He's used the same area of circle, the same area of rectangle, and so on. Right. So diagram B shows the results. So this time he got 1, 2, 3, 4, 5, 6 in and 4 out. So we got 4 in and 6 out the first time, and 6 in and 4 out the second time. So what are we going to be asked to do with that? Right, complete the table. So you've got number of grains of rice inside the circle. So A and B. Remember, A was in diagram A. This is A, so this is when he got 4 in, and this is B, experiment B, diagram B, he got 6 in. So number of grains inside was 4 the first time and 6. Combined results for all 20 grains of rice, well that's number inside the circle, 4 plus 6 is 10. Okay, now these are grayed out because we're not supposed to fill them in. Okay, use the formula to estimate pi for all 20 grains of rice. Okay, so we need to go back. How did we estimate pi before? So if I can just find the sheet where we did it before, was this one. We had area of circle over area of paper, which was the radius squared times pi over the area of the rectangle, length times width, equals the relative frequency. Then we solved for pi. So let's try and do that again. So area of circle over area of paper, we've got it here actually. So area of circle, we know from this part here is 100 pi. So 100 pi over, well, the area of the paper for this part is 30 long and 20 wide. So over 30 times 20 equals the relative frequency, which is 10 over 20. Okay, so now we need to solve this to estimate pi, and I would hope, if we do it right, given that we've got double the trials this time, it should be a better estimate than the 4.8 from the last one. So that would mean pi equals, well, I'm going to put the 30 times 20 up here, I'm going to multiply by that, I'm going to divide by 100. So it would be 10 times 30 times 20 over 100 times 20. And you could just put that straight in your calculator, but if you look at what you've got, I mean, 20 and 20 can cancel out, 1, 1. 10 and 100, you can cancel those as a 10 and a 1. So you end up with 30 over 10 equals 3. If you're not comfortable with that, just put the whole thing in your calculator. Right, so we've now got an estimate of pi as 3, which is a lot better, as we know pi is around 3.14. Right, what's next? Lee draws a circle of radius 12 on a different piece of paper. The circle touches all 4 edges of the paper, so we can see this is a square. It must be a square because the circle is touching. That's a radius. Another radius will go out there, another radius middle to edge will go down there, and another one's going to go up there. So these must be 12, 12, 12, 12. So this is a circle of radius 12 inside a square with side length which is 2 times 12. So this side length here is 24 cm. We're going to need to know that. In these investigations, you're using the same method a lot. It might get more sophisticated, you might bring more variables in, but this is what we're doing. Right, Lee drops 50 grains of rice at random onto the piece of paper. So 50 grains in here. He removes the 50 grains of rice and drops another 50 grains of rice onto the paper. The combined number of the grains of rice inside the circle is 78. Okay, 78. So if he drops 50 grains once and then 50 grains again, then that's 100 grains total. So we've got a relative frequency. Remember, relative frequency, the number of times something happened over the total number of trials. So relative frequency equals the number of times it landed in the circle, 78. Total number of trials we said was 100 because he did it 50 times twice. Area of circle over area of paper. Well, the area of circle is going to be area equals pi r squared, so pi times 12 squared, which hopefully you remember we want it in this something times pi form. So it is going to be 144 times pi. That's the area of the circle. The area of the square is just 24 times 24, 24 squared. So we have 144 times pi over 24 squared equals a relative frequency 78 over 100. So that must mean that pi equals, well, it's going to be 78 over 100. We're going to times by 24 squared up there. We're going to divide by 144. So 78 times 24 squared over 144 times the 100 that's already there. Okay. So we go to our calculator. 78 times 24 squared over 144 times 100. So 14400, but I'll put times 100. Gives us 78 over 25, which you see is 3.12. Now this is really getting a lot closer. B. Lee draws a circle of radius r on a different piece of paper. The circle touches all 4 edges of the paper, so you can see the developments of the way these investigation papers go. You're constantly sort of developing the method. So we had a sort of very crude method with these sort of circles just randomly in the middle of some kind of rectangle. That would be difficult to generalize to algebra, or less, it wouldn't generalize quite as nicely. Then we move into this square method when it's touching and what's kind of circle inside a square. But you've still got numbers. And now suddenly we've got this R. So this will always happen with the investigations. This sort of, the method's constantly being refined and it's going to generalization where you've got lots of algebra. So Lee draws a circle of radius R on a different piece of paper. The circle touches all 4 edges of the paper. Show that for any value of R, the estimate for pi equals k times relative frequency, where k is an integer. We need to find the value of k. So this is going to take some algebra, and I do think it's very unfair. The amount of room they give you to do these things, I don't think it's fair. Especially when it's a show that you've got to do some algebra. That doesn't really seem right. But if we look at what we did in the last one, we had this 12, and then we realized this must be 12, 12, 12, 12. So if this is R, well, this must also be R and R and R. So as far as the square goes, well, this length here must be 2R, because it's just R and then R again. And also this height must be 2r. Well, it's a square, so length equals height anyway. So remember our formula, area of circle over area of paper equals relative frequency. Well, the area of circle is r squared times pi. So we're going to have r squared times pi over the area of the square is 2r times 2r. So we can put 2r all squared or 2r times 2r. I think if I put 2r times 2r, you're less likely to make the classic mistake where you forget to square the two. So that's area of circle over area of square, and that equals relative frequency. So I might just put sort of RF, just because I don't have much space. So that means if we solve for pi, well, actually, let's just see what we can do with this. So this on the bottom is 4r squared. So we have r squared times pi over 2r times 2r, 2 times 2 times r, 4r squared equals RF, relative frequency. So we need to solve for pi, but before we do that, if we look at this fraction, we can just cancel an r squared with an r squared, 1, which makes things a lot easier. So then suddenly, solving for pi, all we need to do is multiply it through by 4. So pi equals k times relative frequency. And our k is just 4. Pi equals 4 times relative frequency. So k must equal 4.